Okay, so isometric projection means it is nothing but a projection of solid or combination of solid by inclining at an angle of 30 degree from any one of the reference points. Okay, so wherein we can see in isometric projection, so there will be 30-degree angle lines. So using those lines we are going to project. So it is nothing but a complete 3D picture of the solids or a combination of solids. Okay, by inclining them at an angle of 30 degree from any one of the reference points. So how do we construct the isometric projection? So here we have two methods. One is box method, one is 4 arc by center method. Using these two methods we are going to construct the isometric projection. And here in when any one of the solids given, right, so it will be having two distances. One is vertical height, another one is horizontal distances per given in any one of the solids. Okay, so vertical heights given in solid will be drawn vertically in the isoscale. Okay, vertically in the isoscale, so there is no change if the vertical heights were given. Okay, so that will be drawn vertically in isoscale. But if any of the distances were given horizontally, so the horizontal distance were drawn in the 30-degree inclined lines. So in the isoscale, so there are 30-degree inclined lines for the right. So in those lines we are going to draw the horizontal distances. Now we come to the sphere. Okay, sphere is the only solid which will be drawn with the actual scale here. Okay, because except sphere, all the solids will be drawn with the isoscale. So in sphere, what happens exactly here? If we are going to tilt a sphere at whatever the angle, 30 degree, 40 degree, or 50 degree, we will get the same circular weave here, the top weave, front weave. Okay, so by inclining at whatever the angle, 30 degree, 45, 60 degree, we will get the same wave. That's why the sphere will be drawn with the actual scale. Okay, so remember, so sphere will be drawn with the actual scale. Except sphere, all the solids were drawn with the isoscale in the isometric projection. Okay, today we are going to start about isometric projection. Okay, so isometric projection, it is nothing but a projection of a solid or a combination of solid by projecting at an angle of 30 degree here. Okay, so you can see here we have 30-degree inclined lines. Using these lines we have to do the isometric projection. So in this isometric projection, so we see the first problem. A sphere of diameter 50 mm rests centrally on top of a cube of sides 50. So there are two solids given, one is sphere and one is cube. Cube of sides 50 and sphere of diameter 50. So you can see that sphere of diameter 50 rests centrally on a top of a cube. That means first we have to construct a cube here of dimension 50. Then after that we have to do the sphere. Okay, first I'm going to draw a reference line here. Okay, so reference line I'm drawing here. Okay, I'll take reference point here. So now we are using box method to construct the cube here. So cube of sides 50 mm. So I'm drawing box of 50 here. 5 box. 1, 2, 3, 4, 5. Okay. And similarly 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So box of 50 mm it is drawn. Now we know that in a cube we have vertical height also same thing, that is of 50 mm. 50 mm is again 5 box. 1 vertical height 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Okay. So now we have to join with the top face of the cube. Okay. I'm joining with the top face of the cube here. So you can see that we have constructed a cube. It is somewhat similar like a hexagon. Okay, so we have constructed a cube. Above it, centrally we have to place a sphere of diameter 50. So centrally means first we are going to find out the center of the top face. Okay, center of the top face. Here it is 50 means exactly at 50 means 2.25. 25 means 2.5. We are going to mark. Okay. Okay, this is our center point. So from this center point, you see we have to construct a sphere of diameter 50. We have to consider a height of 25, say 5, 10, 20. So 25 here, 15, 5 here, 15, 25. So this is what the center point. And here a sphere will be drawn with the actual scale. Okay, sphere is the only solid which will be drawn with the actual solid. Except a sphere, all the solids will be drawn with the isoscale. Only the sphere which will be drawn with the actual scale. Okay, remember it. So sphere will be drawn with the actual scale. So always remember it, because if we are going to incline sphere at whatever the angle, it is 30 degree, 40 degree or 50 degree, you will get the same circular shape only. So there is no change in the shape in case of your sphere. Okay, so remember it, sphere will be drawn with the actual scale. So this is our sphere and this is our cube. So you can show the angle. Here it is 30 degree and here also 30 degree. Okay, sphere will be drawn with the actual scale. So remember it. So this completes the problem. You see the second problem in isometric projection. So you can see the question here in two solids given. One is hemisphere. Okay, hemisphere of 40 mm diameter. Hemisphere means it is nothing but the half part of the sphere supported coaxially on the vertex of a cone. So the second solid given, it is cone. So for that cone they have given base diameter 60 and axis length 50. So that means we have to construct the cone first, then after that we have to construct the hemisphere. Hemisphere means half part of the sphere. Okay, now flat circular face of the hemisphere facing upside. Okay, so first we are going to construct the cone here. So for the cone, the base diameter given 60. Okay, so first we are going to take the reference line here. Okay, reference line. So here you can see that base diameter 60 means we have to do the 6 boxes here. 1, 2, 3, 4, 5, 6. Again here 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. So we have to construct the 6 boxes either side. The 6 box it is constructed. Now you see that the base part of the cone, it is which is given with the diameter 60, means it is in circle. Okay, so when the circle it is constructed in iso, it will become ellipse. Okay, it will become ellipse. So how to construct the ellipse, I will show. So herein to construct an ellipse we have to go for 4 arc by center method. Okay, first I am going to mark the middle point of all the edges. If it is 60 means exactly you can mark at 30 here. Okay, 30. Now I'm drawing the lines here like this, arrow lines you can draw here. Okay, so like this 4 lines you have to draw. Then after that we have to use compass here. Okay, using compass, by measuring this length, okay, I have to draw first arc. Okay, then again from this point, so measuring this length, so measuring like this. And then third point, we have to measure this from this point using compass. Third arc, next fourth, measuring again this distance. Okay, so we have constructed an ellipse. Okay, so this is what the base diameter, when it is constructed in ellipse, it becomes a it is a base part of the cone, 60 mm diameter, circle converted into ellipse in the ISO. Now we have to find out the center. We have an axis length, right? So center of the box here, like this. This is the center of the box. From this we have to consider a axis length of 50, that is 5 boxes. 1, 2, 3, 4, 5. So draw an vertical height of here 60. Now we have to draw an connecting tangentially. We have to connect like this tangentially to make sure the surface of the cone has to touch like this. So this completes the cone problem. Now we have to place the hemisphere, which is having a diameter of 40. So 40 means again we have to construct a 4 box here. 1, 2, 3. That is 40 mm box means 4 box. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it is done. Okay, 4 boxes. Again you can see that hemisphere means it is the half part of the sphere, so it is in circular. So when it is constructed, it is circular means when it is constructed in ISO, it will become ellipse. Okay, so again I am marking the middle points here, the point of the box. Now using compass we have to cut the arcs here. This length. Okay, again from this point, so measuring this length. Okay, so it is done. So now again we find out the center of the box here. Okay, from this center point, so how to construct the lower part here, from this point to here, exactly here we are going to take and then join it like this. Okay, so this completes the problem. Here you can see this is our 30 degree, so this it is cone and this is hemisphere. You can see that this flat circular face, it is facing upside. So this completes the problem. So you can like the video. So herein we will be encountering frustum in isometric projection. Frustum means it is nothing but a cutted portion of the solid. Okay, cutted portion of the solid. So when we encounter two types of frustum here: frustum of pyramid and frustum of cone. Okay, so what happens in the frustum of pyramid, it is if it is given frustum of square pyramid means, so both the top face and bottom face will be in square here. Okay, will be a square with the height, that is axis height is given. Okay, so that's what the frustum of square pyramid. You can see frustum of pentagonal pyramid or hexagonal pyramid means say the top face and bottom face will be same here. In the same case we can find in the frustum of cone also. In frustum of cone, the top face and the bottom face will be in circle here, So with the height or axis it is given. Okay, frustum means understood, it is nothing but a cutted portion of a solid. Okay, that's what the frustum is. Okay, we see another problem in isometric. So here in this problem they have given the frustum of a square pyramid. Frustum means it is a cutted portion of a square pyramid of sides 40 mm and height 60 mm and top face 20 mm. Okay, so frustum means understood, it is a cutted portion of the square pyramid wherein the top face and the bottom face will be a square. The top face it is 20, bottom face it is 40 and height given 60. So rest on the center of a top of a square block. So okay, square block of side 60 and height 20. So first we need to construct a square block of 60 and height 20. Above it we have to place a frustum of the square pyramid. Okay, so first I'm going to construct a square block. Okay, so square block I'm constructing here, just taking reference point here at this point. Square block of base side it is 60, that means 6 blocks, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. So we need to construct a box of 6 here for the 60 mm. Okay, so now you can see that vertical height of 20. So height of 20 means from all these corners we have to consider a height of 2 boxes. So now we are going to join it. So square block it is constructed. Now you see that we have to construct a frustum of square pyramid of sides 40, base side it is, and height 60 and top face 20. So we need to get a square of 40 here, but here in we have 60. So how to get the 40 means herein we go for the subtraction of the box method, that is say 60 minus 40. The base we have, that is 60, we require 40, so it means 20. 20 by 2 means it is 10. So we need to subtract by 10 mm on each side. Okay, so 10 mm means one box distance. Okay, understood. So 60 minus 40, 20, 20 on either sides being divided by 2, so it is 10. 10 means one box, so we need to subtract by one box on either sides. You can see that. So on either side we have to subtract. Okay, so it is nothing but subtraction of the box method. Okay, subtraction of the box method. So it is done. Now we see that, so this is our box. Okay, this is our square box. Okay, so you can see that square box it is constructed. Height also we can give 6 box, and then top face of 20. So in order to do that, another box of 20 required at a height of 60. So how to do that? Say from this 40 mm box I will be considering 6 box distance here. 1 2 3 4 5 6 here. Okay, similarly from this end 1 2 3 4 5 6. Again from here 1 2 3 4 5 6. Again from this end 1 2 3 4 5 6. So another box you can construct here, that is 40 by 40. Don't draw vertical line here. So we have to construct a frustum here. Okay, you construct here box of another 40, but we here the top face we require a box of 20. It's again subtraction of box method. So 40 minus 20 is 20 on either side means divided by 2, so we get 10. So subtract by 10 on either side. Okay, subtract by 10 on either side. So this inside box, okay, this inside box is our 20 by 20. So it is 20 box it is. Okay, here we have this box, which is this one. I'm going to dark it 50 by 40. Okay. So this from here to here we have to join. Again from here to here, from here to here, from here to here we have to join. Okay. So because it's a square pyramid and we have slant edges, right? So we can show like this. So we have to construct. So this completes the problem. This is 30 degree and this is 30 degree. This is square block. This is frustum of square pyramid. Okay, so this completes the problem. Okay, we do another problem in isometric. So you can see in this problem, so there are two solids given. One is cone of base diameter 30 and height 40 mm, rest centrally over a cube of side 50. So first we have to construct a cube. Okay, cube of dimension 50. So over it, so we have to construct a cone here. So cube of dimension 50 here, 5 sides. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 3 4 5. Okay. Okay, vertical height of 50 here, that's 5 boxes. One, two, three, four, five. Okay. 1 2 3 4. So it is also 5. So cube of dimension 50 it is done. Now centrally over it we have to place a cone of diameter 30. Okay, cone of diameter 30 means say subtraction of approximately is 40 minus 30. So 40 minus sorry it is 50, right? 50. So this is 50. We need to get a cone of base diameter 30. So 30 means 20 divided by 2 means 10. So 10 on either side. So we subtract by 10 on either side diagonally like this. So here we get a square of 30 here. Okay. So base diameter means it is in circle. So that means so we have to go for 4 arc by center method, marking the middle points. So using compass. we constructed a cone. So the cone of height 40 here. Axis from exactly center. Center point. So 1, 2, 3, 4. So axis height 40 here. Connect tangentially here. Okay. So this completes the problem. See this problem number 10 in isometric. A pentagonal pyramid of base height 30 and axis length 60 is resting on HP on one of its base with the side perpendicular to VP. So first we have to construct a pentagon with respect to 30 mm dimension. With the actual scale we have to do it. Then after that we have to construct the box here. Okay, we need a box to construct the pentagonal pyramid. So we have to construct the box here initially. Okay. So like this we have to construct the box here, and now we have to find out the dimensions here. Okay, so this is around 20 28 28 we're getting 28 something, 28.5 something. So these dimensions we require. How much we have? 28 point something, and these dimensions also we require here. So it is how much is around 25. Okay, and then this dimension also required. This is around 9 mm, we get it. Okay, 9 mm. Okay, so here in what I will do, I am going to give this is A, B, C, D, E, and for this box I give 1, 2, 3 and 4. So now using this box dimension we can easily construct the pyramid here. So I'll be taking this reference. Okay, now so first I'm going to measure this box dimension. This is around 49 we have. It is around 49. Okay, it is around 49, and this is around 45. Okay, so 45. So that means if I am starting from 1 here, okay, if I am starting from 1 here, so 1 to 2 we have 49. Okay, 1 to 2 we have 49. 1, 2, 3, 4, 5. So less than 5 I am going to mark approximately 49 here. Then similarly here 45. So 2 to 3. So this is 2. 2 to 3 we have 45. 1, 2, 3, 4, 5. So exactly here I am going to end here. So this is 0.3. And again 3 to 4 I have 49. So 49 means 1, 2, 3, 4, so 5. So around I'll be getting 1, 2, 3, 4, 4. So somewhere here to get, so this point we have 4. So now we can join it. So now 1 to 2 it is 49, 2 to 3 it is 45, again 3 to 4 is 49, again it is 45. So we have to construct the box first. Box of the box it is done. Now you can see that from 1 to A it is 9. 1 to A it is 9, around 9 I mark, 1 to A 9. Again from 2 to B is also around 9 mm, so it is 2 to B. Okay. Then 2 to 3 it is 28, so 10, 20, 20, 28 means here we will get this is C. Again 3 to the D is 25. Okay, approximately I'm going to mark 10, 20, 25. I'm going to mark here, this is D. And again from 1 to E it is 28, 1 to E it is 28. So now we are going to join. So this completes the pentagon. Okay, now we have to take center of this pentagon. Approximately I'm going to draw 3 lines here, perpendicular bisectors. Okay, 3 lines if I draw with the center. Okay, center point I'm getting. So the axis length it is 60. From this point you have to consider your axis length of, say, vertically here. We need to count the box. So just I'm keeping the scale for reference. We need to count the box. Okay, from this end 1, so 1 we have this 1, 1, 2, 3, 4, 5, 6. Okay, here. So vertical it is axis we have to draw for 6 boxes. Okay, we have to count the boxes here, 1, 2, 3, 4, 5, 6. Okay, now we are going to join with the slant edges. Okay, so this completes the pentagonal pyramid. Okay, so this completes the pentagonal pyramid. We do another problem on isometric. You can see here we have to construct a sphere of diameter 45 centrally over a frustum of cone base diameter 60, top face 40 and height 60. So that means first we have to construct a frustum of cone. So 60 means 6 boxes here, 2, 3, 4, 5, 6, 3, 4, 5, 6. Okay, 60 by 60 box. So middle points we have to mark. Now so top face center, so height of how much, 60, there is 1, 2, 3, 4, 5, 6. So here also 1, 2, 3, 4, 5, 6, another box. Okay, 60. So within this box we have to take 40 means 10 mm on either side. We'll get a box here by subtraction of box method. So subtraction of box method, getting so we can construct another ellipse here. Okay. So another ellipse it is done. So above it we have to construct 2.5, that is here exactly the center. To take 22.5, so 22.5 will take, and here I'm going to draw a circle. Okay, so this is nothing but a sphere. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism, okay, of base side 60. So base side 60 it is 1 2 3 4 5 6 1 2 3 4 5 6 1 2 4 5 6. Okay, so you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1 2 3. Vertical height of 30. Cube it is constructed, cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. See that box of 50 here. You can count to 1 2 3 4 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50 center resting top of square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get it here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So height of 25 we have to construct another box here. 1 2 2.5 here. Similarly 1 here, 2.5 here, 1 2.5. So here 2.5, another box of 50. Here we get at a height of 25. Another box you have to construct. Okay. So after constructing it, again for arc center method, marking the middle points. So 5 means 20, 1, 2, 3, 4, 5. So 25 means here. Exactly 25, 20, 25, 25. So construct ellipse here. Okay. So now we can draw here diagonal. Okay. So from exactly the center, so measuring this length, so I can construct the curved face of the, you can see that here, curved surface. So we are going to find out the center first, okay, then we'll take the length. Okay, so to find out the center, it's exactly the center points you have to take. Center point here I'm getting. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism, okay, of base side 60. So base side 60 it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1, 2, 3. Vertical height of 30. Cube it is constructed. Cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. Select a box of 50 here. You can count to 1, 2, 3, 4, 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50, center resting top of square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get it here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So the height of 25 we have to construct another box here. 1, 2, 2.5 here. Similarly 1 here, 2.5 here, 1, 2.5. So here 2.5, another box of 50. Here we get at a height of 25. Another box here to construct. Okay. So after constructing it, again 4 arc center method, marking the middle points. So 5 means 20. 1, 2, 3, 4, 5. So 25 means here. Exactly 25. 20, 25. 25. So construct ellipse here. Okay. So now we can draw here diagonal. Okay. So from exactly the center, so measuring this length. So I can construct the curved face of the. You can see that here, curved surface. So we are going to find out the center first. Okay. Then we'll take the length. Okay. So to find out the center, it's exactly the center points you have to take. Center point here I'm getting. So this completes the problem.